Everyone, welcome to chemistry class. We are here with the chapter number 6, metals and non-metals. In this video, we'll be having a revision of the exercise part. Although all the answers have been provided to you in the live classes on the Teams app, we'll have a revision of the exercise, the question answers of this chapter. In case you have not understood any of them, you can watch this video. Question number 1 will begin with a short answer. Question number 1, name any 10 metals. So any of the 10 metals you can write. So that is only the names you have to learn in this, nothing to explain here. Question 2, metals have high tensile strength. Explain, also give one example of how this property of metal is used. Answer is, metals are having high tensile strength. What is tensile strength? That is a property to carry loads. The metals are having this property. We'll continue reading. That is, they are strong enough to bear heavy loads. Example we'll read here. Metal ropes are used in the ropeways for transporting heavy loads. That is in the hilly areas it is done. Question 3rd, A part. Why can't you draw wires from a piece of sulfur or coal? So because sulfur and coal are brittle. Brittle means they are weak, non-flexible and non-ductile. So ductility is the property by which we can convert any metal into wires, like aluminum wires, copper wires are there. That is just because they are ductile. But the non-metals, sulfur and coal, are non-metals and they are non-ductile. That is why we cannot convert them into wires. See, and then the B part. Why can't you use nylon or jute ropes for electrical transmission? Answer is because nylon and jute are the bad conductors of electricity and cannot pass electricity. Here also nylon and jute ropes, if we make, they will be made of non-metal. Nylon and jute both are non-metals, and non-metals are bad conductors of electricity. They cannot conduct electricity, therefore they are not used to prepare in the case of the electrical transmission. The C part now. Why can't you use a cooking utensil made of carbon? Answer, because carbon is a bad conductor of heat. Carbon again is a non-metal. It is a bad conductor of heat. It cannot distribute the heat all over the utensil. Metals can do so, but non-metals cannot do so. They are bad conductors. Metals are good conductors of heat. So because carbon is a non-metal, we cannot make any utensil of carbon. Also carbon will start burning. If you make utensil of carbon, it will burn and it will produce carbon dioxide gas. So that is why we are not making utensils by using carbon. Question 4, name 5 non-metal which are gaseous at ordinary temperature. Answers are given here. Hydrogen, nitrogen, oxygen, fluorine, chlorine. All these are gases only at normal temperature. Question 5, mention 3 uses of iron. First part is, iron is used in construction of building to give them enough strength, that is based on its tensile strength. Second, iron coated with tin is used to make car, then the body of the car is made of that. Next, third, it is used for making furnitures. So these are the different uses of iron. Next, 6th question, mention 3 uses of aluminium. First part, electricity wires are made of aluminium. Second, it is used for making utensil. And third, it is useful for making foils for packing food and medicine. These are the various uses here of the aluminium metal. Question 7, define an alloy. What is an alloy? Answer will read, when a homogeneous mixture of metal is mixed with other metal or non-metal, it forms an alloy. What is a metal? Metal plus metal or metal plus non-metal. It is always called as an alloy. You have to remember one fact here. Whenever we are preparing an alloy, in that mixture of alloy, minimum one metal should be there. We cannot mix 2 non-metals and prepare an alloy. Non-metal plus non-metal will not give an alloy. Always there has to be minimum one metal combined with a metal or non-metal. It can be 2 or 3 or 4. Any number of metals can be mixed, or non-metals can be mixed with a single metal. That is an alloy. It is a homogeneous mixture. Homogeneous means all the molecules will be equally distributed in the mixture. So that is a homogeneous. If it is not equally distributed, it will be called heterogeneous. So always remember, alloy is a homogeneous mixture. In this, the molecules of all the metals and non-metal, whichever we have mixed there, they are equally distributed. Question number 8 now will be, what do you mean by the corrosion of metal? The slow destruction of metal or alloy by chemical action is called corrosion. This chemical action is generally caused by the air, and in air it is generally by oxygen, and because of that chemical action only the metal or the alloy body will slowly decompose, that is slow destruction, and this is called as corrosion. If corrosion take place in the iron, it is called as rusting. That is it can be asked separately, not in this answer. You don't have to write the definition we have seen of corrosion. We'll move to the question 9. Give the word equation for rusting. Rusting is a type of corrosion only, and if the corrosion takes place on iron metal, then it is called as rusting. We'll read the equation. Iron plus oxygen plus water gives rust reddish brown. Only the word equation they have asked, so we have not used any chemical formulas. The chemical name of rust is iron second oxide, Fe2O3.XH2O. That will be the formula. What is possibly the reason why the iron pillar of Delhi has not rusted yet? Answer 10 we'll read here. Because it is made of pure metal and does not have impurities. That is why only this metal in the iron pillar has not rusted. Even for centuries it is present there. Question 11. What are metalloids? Name a few. Elements which are having the properties of metals as well as non-metals are metalloids. For example, boron, silicon, etc. So these are metalloids. They are showing the properties of metals and partial properties of non-metal. They are behaving as both metal as non-metal, called as metalloid. This is a special category of the elements. Mostly elements are metal and non-metal, but some elements are behaving both like metal and non-metal. They are metalloids. Example is boron, silicon. Many more are there, but only this much is required for here. Long answers will move now. Question 1 of the long. So long one, mention any one physical characteristics of metal. Physical properties have been asked. Point 1, metals have a luster known as metallic luster. Example, aluminum, iron. All these are shining. That shine of the metal is called metallic luster. Second, metals are sonorous, that they can produce sound. Example, ringing of a bell. Whenever you hit any object on the metal, they produce a sound like a ringing of the bell. So that is why we can say metals are sonorous. They produce a sound. Third point, metals are good conductors of heat and electricity. They allow heat and electricity to pass through them easily. So, like copper, aluminum are used for making wires. So that is why we can say they are good conductor of heat and electricity. Heat can be transferred. That is why different utensils are made of copper. So fourth point now, metals are malleable. Example, iron and aluminum. That is, they can be beaten into thin sheets. When you are regularly hitting any metal object, it will compress down into a thin sheet. Like aluminum, even foil paper can be made, used to pack the food and medicines. So that is made of aluminum. That is a strong metal, but if you regularly beat it, it will convert into a foil paper only. Easily you can fold it. So that is based on the property of malleability. Metals are malleable. Point number 5, metals are ductile. That is, ductility is the property. What is happening in this? That the metals can be drawn into wires. We can convert the metal into wires, like copper, silver, gold. All these can be converted into wires used in various appliances. Gold is used in the jewelry and all. So this is based on the property of ductility. Question number 2 now, what are the physical properties of non-metals? So what we have seen in the first question of the long, just opposite properties we will see now here. The physical properties of non-metals are as follows. First point, solid non-metals are non-lustrous. They are not shining. Most of the non-metals are liquid or gas. Mostly are gases only. So very few non-metals are solid, and if they are solid also, they are not shining. Only one exception was there that you can see in the book. That is, graphite is a non-metal which has shine. Otherwise, all the non-metals are non-lustrous, solid ones. Second point, solid non-metals are not hard and they have low tensile strength. They cannot carry weight. If you keep heavy load or heavy weight on the non-metal, it will break. They are very weak. They are not hard. So third point now, non-metals are non-sonorous. If you hit any object on the non-metal, it will not produce the sound like the ringing of the bell in the metals. So that is why they are non-sonorous. They do not produce a metallic clink sound on hitting of an object. Fourth point, they have low densities, and fifth point, they have low melting and boiling points. These are the properties, physical properties of the non-metals. Question 3 now, describe an activity to show that the lead of a pencil, this is not lead, this is lead of a pencil conducts electricity. The lead of the pencil contains graphite. So graphite, basically they are asking graphite conduct electricity. Graphite is what? It is a non-metal, and non-metals do not conduct electricity. Graphite is an exception. It is a special case in the non-metals. Normally, non-metals are bad conductors of heat and electricity. But graphite, in spite of being a non-metal, it can conduct electricity. So we have to prove this with the activity. And what else they have asked? But a piece of sulfur does not. So let us read here sulfur and lead, both we will see. Let us read the answer. Sharpen a small pencil at both ends and connect the two naked ends of the lead to the circuit. So we will take a pencil and sharpen it from both the sides so that the lead of the pencil, the pointed tip of the pencil will appear there. And on the tip of the pencil that is used for writing, so on that only you will connect the wires on both the sides. Both the sides you have sharpened it. Then on the lead of the pencil only connect a wire. Both the sides of the pencil you have sharpened and both the sides you have connected the wire. And when you have connected it to the wire, you have to connect it to an electrical circuit. In that circuit, current will flow. As a result of that, the bulb that is present in that circuit, electrical circuit, it will start glowing. You can refer to a photograph that is given related to the experiment in the textbook. So if the bulb is glowing, what does it show? It shows that the lead of the pencil conduct electricity. It means it is a good conductor of electricity. That is how we can say the lead that is made of graphite conducts electricity. It can work like an electric wire only. It can transfer the electric current from one place to another, used to transmit electric current. Second paragraph we'll read now. Now we'll remove the pencil from the circuit. Now what we'll do? Now connect a piece of sulfur instead of the lead with the circuit. We have taken the pencil and in place of that pencil we have put in that same electrical circuit we have kept sulfur. Sulfur we have connected with the electrical wire, and if we turn the switch on, now bulb will not glow. Why does the bulb not glow? Answer is because sulfur is a bad conductor of electricity. So that is how by this activity we prove that lead of the pencil conduct electricity, but a piece of the sulfur does not conduct electricity. That is all for this answer 3. We'll move to the question number 4. Describe 3 methods to prevent rusting. Answer will read, methods to prevent rusting are, first point, applying a paint on the metal surface. We can do painting. So by painting only, what will happen? This paint will protect the metal from the chemical action of the air. Second point, a metal object can be dipped in molten zinc so that a layer of zinc forms on the surface. This is galvanizing. So by galvanization also we can prevent rusting. Generally iron is galvanized. That is called as GI iron. Galvanized iron. So the galvanized iron is how it is done. We can take any iron object, it is in the factories, iron object is taken and it is dipped in molten zinc. Zinc is a solid, but on heating it converts into a liquid, it melts down. So when the zinc has melted into a liquid, it is called as molten zinc. So in that liquid of zinc, we will dip an object of iron. When we have dipped it, what will happen? This zinc will deposit all over the iron object, and hence zinc will protect the iron from outside air, from the chemical action of the air, and now rusting will not take place on that object made of iron. Originally the object is made of iron. Zinc is forming a outer layer so that the rusting will not take place. Second point we have seen. Third point, depositing a thin uniform layer of one metal over another by electrolysis. In this also same concept, over one object we will one object is made of a metal, that object can be protected by forming a layer of another metal by the process of electricity, by passing the electricity by the process of electrolysis. So these are the different methods you have seen. Point number 5, question number 5 now. Describe an experiment to prove rusting takes place only in moist air. Moist air means air with water vapor. So let us read here. Take 3 test tubes, A, B and C. We have taken 3 test tubes. First test tube, what we will do? We will put some nails in the test tube A, add some tap water, dilute acid. So in the first test tube we have taken tap water and only acid is there. Second test tube now, we will put some distilled water there and boil it. Second test tube, we have taken the iron nails put some distilled water and boiled it. On boiling, what will happen? Air will be removed, and then we will pour oil over the water so that the air cannot enter that water again. Third point, put some quicklime in test tube C and some nails, place a cork so that quicklime can absorb the moisture within a closed space. So 3 test tubes we have taken. Let me show you diagrammatically here. First test tube, what we have done? In the test tube A, we have taken iron nails. These lines you can assume as iron nails. And then we have added water also there. What else is there? Water also is there. 2 things are entering here now. Water is also there. Air is also there. So if both the things are available, what will happen? Rusting takes place. Rusting will also happen in this case because air and water both are available. In the second test tube, what happened there? In the second test tube, we have taken some iron nails and we have added water and boiled and put oil over the water. So in this test tube, water is available, but on boiling, air has been removed, and above this, what we have taken? Oil we have taken. Now if air wants to enter, air will not be able to enter because oil is deposited here. So in the test tube B, rusting does not take place because water is there but air is not present. In the third test tube now, we have taken third test tube, iron nails are there and quicklime is there. Quicklime is one of the chemical called as calcium oxide, CaO. This is the formula of calcium oxide, of the quicklime, calcium oxide. This will absorb the water vapor. What this will do? It will absorb the water vapor and we will close this with a cork. This test tube is closed now. Now because it is closed, inside this test tube what is present? Air is there and this air is dry. Dry air is there. Why the air is dry? Because quicklime has absorbed all the water vapor. That is why it becomes dry. So if air only is there and water is not there, then also rusting will not take place. So what is the observation? That is only the test tube A, rusting will take place, others will not take place. Because for rusting, moist air is required. That means water vapor and oxygen gas, yani ki air, both are required. Oxygen and water both are required for rusting to take place. If both are available, like in the test tube A, rusting will take place, otherwise it will not take place. If only water is there, air is not there, then no rusting. Same way, if only air is there, water is not available, then also no rusting will take place. Both the conditions are compulsorily to be available, air as well as water. That is only when rusting can take place. So that is all for the explanation of this exercise part. Some book exercise questions are there, 1 mark questions. You can refer to them in case you have not noted down from the live class. You can refer and note these questions from here. So that is all. We will end the video now of this chapter number 6 exercise part. That is all. You can refer from here. If any doubt still is there, you can post your doubts in the comment section below. Also you can send the message personally in the Teams app in the personal chat and you can clear your doubts. Thank you for now.